you want something kind of cool? This is a piece of aluminum. If you haven't seen my video on induction before, go ahead and check it out. But I'm going to be very brief here. Essentially what happens in a metal conductor like aluminum is if you have a changing magnetic field, it produces currents inside to oppose that change, making its own magnetic field. But today we're not going to get into the details of that. We're going to talk about an application, which is making a motor, in this case an induction motor. What I have here are electrical magnets, electromagnets, and they're going to switch their orientation in a phase. So the way you can think about that is there's a north and a south pole magnet, essentially. It's going to switch from north to south, south to north, and they're switching. Now, when I turn the current on, you'll notice we start getting rotation, and that's because this thing inside is generating its own field. It wants to align, so it wants to align with the magnetic field, but then that switches. So now it wants to align here, but then that switches. Then it wants to align here, and that switches. And so this is constantly changing in phase. That's why it's called a three-phase motor. There's three phases, and so it's constantly spinning it. And now we have a motor with no electrical connections to the rotor, which is very nice for industry. There's lots of applications for these three-phase induction motors, because you can have a motor that doesn't need to be connected to anything on the outside. Pretty cool.